Okay, guys, in this video, we are going to take a look at finding the area of a parallelogram that's formed by its four vertices. So here, what I did is also plotted the points for you so that you can see that they form a parallelogram, right? So here, the 4 points, you can see that the sides are parallel to each other, right? So this is a parallelogram in space. And what we want to do is find the area. Okay, so the way we find the area is we have a formula through the cross product. So for the area of a parallelogram, what you need is two sides of this parallelogram and they should be adjacent to each other. So this is going to be U cross with V. But what is what? So just imagine that I'm drawing a parallelogram and this side, for example, is U and this side is V. Then if I cross the vectors and then find the magnitude, that's going to give me the area of the parallelogram. So for example, if this point is P, this is Q, this is R, this is S, then you can take, for example, PQ and PS and cross those. It doesn't matter which ones you take as long as they're not parallel sides. They should be adjacent sides, right? And then because you're taking the magnitude, that's going to be just one number because remember cross product is a vector. So that can be an area of anything. But once you find the magnitude, that's just a number. And it's a positive number. So that should make sense. Now, if they ask you rather to find the area of a triangle and give you three vertices of the triangle, then what you do is something different. Well, no, you're not, because you're just going to take half of a parallelogram, right? So this area right here would be half of the whole thing. So just find the area of a parallelogram like before and then just divide it by 2 at the end. Okay, so that's the idea, but let's go ahead and compute it. So first, we're going to take PQ. So remember to subtract the coordinates of point P from Q, right? Which actually doesn't matter in this case because you're going to be taking magnitude anyway, but whatever. So we're going to take 4, subtract -1. We're going to take -4, subtract -3. And then the z coordinate is going to be 0, subtract -2. So it's a lot of negatives. We got to be really careful here. So this is going to be 5. This is -4 plus 3. So that's -1. And then that's 2. Okay. So we found PQ. Let's find PS actually. We definitely don't want to take it diagonal. We want to find two sides. So PS. Okay. So we're going to subtract coordinates of P from S. So that will be 5 subtract -1, 0 subtract -3, and then 5 subtract -2. Okay, so that will give us 6, 3, and 7. Okay, so the next step is to actually cross these vectors. So find the cross product. So for that, we are going to draw the determinant, right? We're going to put I, J, K in the numerator. The order of these in this case again doesn't matter because we're going to be finding the magnitude. So even if we had the opposite vector, that's okay. But I'll just leave them as PQ and PS. So for I, we are crossing this row, this column, right? And remember, we multiply the diagonal elements. So -7 subtract -6. So that would be -13. Then J is taken with the negative. So this is where we are going to cross out this row, that column. And then we're going to take 5 times 7, right? Which is going to be 5 times 7, 35. And then we're going to subtract 12 from there. And then the K is where we cross the last one, right? So let me take this thing and move it over here. So that would be 5 times 3. So that would be 15, subtract -6. So that will actually be +6. Okay. So my final answer is -13. This is going to be 35 minus 12, so that's 23. But because J component always comes with a negative, that's going to be minus. And then this is 15 plus 6, that would be 21. Now, just to check this out, let's see if we can compute the dot product of each vector and the cross product I found. So remember the dot product, we just multiply the corresponding elements and that should give me 0. Okay, and then I'm gonna also check the same thing with the second vector. Oh, Okay, so that's 0, which means that we got the cross product correctly. So at least that part is right. All right, so the next step is to just to find the magnitude of it. So when you find the magnitude of the cross product, that just means that we are going to square each component, add them up, and then take the square root of the answer. So I do not ever recommend including the negatives just because you might, get into trouble with parentheses and everything. So don't do that. Okay, so I got some ugly number, square root of 1139. And that's what we want to put here. And let's check this out.